Alright guys, so I am using the NVIDIA broadcast, which has AI noise removal, because as you can see over there, it's 98 degrees outside, so hopefully it doesn't distort my voice too much, but it does have a tendency of distorting your voice when there's a lot of white noise in the background. Anyway, I told you guys I was going to redo that overview video. This time I completely laid all this stuff out over here to help me keep track of everything and make sure that I cover everything. So as you can see, there's a lot to cover. This is going to be a long video. Let's get started. First off, this is a project that is evolving, and it will evolve over time. So you should expect it to. It'll change a lot. I may have to do other videos on this, but I'm going to be reluctant to continuously do update overview videos like this. So I think for the most part, the structure of it is pretty stable. I know I've said that before, but it's more of a final stable state, I think, as far as the structure. I don't see it changing drastically from here on out. But anyway, a lot of the stuff still works the same way. It's just things have changed a bit. I'm going to go ahead and get started on folder structure. And I did not expect that to ding when I pressed it. But this is the first time I've used this, by the way. So anyway, folder structure. We have blueprints and we have character. That's where our stuff is under. So it'll be labeled DAO, the folders will. So under the character, I do have some remnants of ALS poses that I have used. As you can see, these are the ones that I actually imported and retargeted. And then I modified them inside of here using IK, using the control rig. But anyway, I digress. So over here in the UEFN mannequin folder, you'll see animations. And you'll see DAO anims. This is where the animations that I imported, made, and modified reside. So some of these are ALS animations. This one's an ALS animation. I did not correct this one. This is how it was when it came in. I may have offset the pelvis so it was actually touching the ground. On the breathing one, I had to modify it so that the hands are in sync because the hands are not in sync, so on and so forth. The aim sweeps, I actually did make these, believe it or not. Those aim sweeps are not from ALS. So, and if you look at the ALS ones, you'll notice that mine are actually backwards. I didn't intend for them to be backwards. I just made them and then realized they were backwards afterwards. That's all right. They still work the same. So mine starts looking down and then goes to looking up. The ALS ones start from looking up and go to looking down. So we're not covering that right now. We're talking about the folder structure. Over here in the DAO folder structure, you'll see some chooser tables. This is what I'm actually not using this one. I'll probably delete it. I don't even know why it's there actually. I'll delete it now. So anyway, when you get this, it'll still be there. In the next update, it'll be gone. But the chooser table is how we choose which layering data settings get loaded. I'm not going to go into that yet. I have that planned for later. But that's the chooser table, so that you'll know that's where your layering data is. And I'll go over that again later. Your layering data settings are inside of here. And then your held objects are inside of here, and they're in their own folders. They have their own data assets that store their layering settings, and that gets loaded based off of a chooser table. I'm not actually using this one either. This is a remnant of an older version. I'm not using that. All the data assets, they're all using this one chooser table. So if you see some inside of here, these aren't even being used. And if you want to know, you can say reference, and you'll see there's nothing over here connected to it to the left. That would be things that that are referencing it. The ones on the left are the ones that it's referencing. The ones on the the ones on the right are the ones it's referencing, and the ones on the left are the ones that are referencing it. The meshes are under here. Same with the M9. You'll see it didn't have a chooser table in there. And then the projectile. The projectile is the thing that you shoot. So this looks like my screen froze. If your screen ever freezes, it's a long-standing 5.0 bug. It's been in there ever since they released Unreal 5. They have not fixed it. They may never fix it. I don't know. At this point, I doubt they'll ever fix it, but it's still there, and it's been there for years. I wish they would one day fix it. But anyway, sorry. It's aggravating that they haven't took the time to fix that. So I will have some better transition animations in the future. I'll have reload animations. I'll have animations where he actually puts his gun away before he gets up here. So that'll be in a later version. I plan on adding foot locking, but don't hold your breath. I'm going to try my best, but foot locking is a pretty complex system, and I can't do it the way that most people do it in here because of the way that they handle the root bone. So yeah, that's going to complicate things. So anyway, I am studying it and mapping it out and working out the logic and looking over it and deciding what I need to do differently in here for motion matching because of the root bone problem. The root bone moves independent of the mesh itself. Therefore, you can't just use the mesh to calculate things like basically everybody does in every game ever. So it kind of breaks all traditional methods or approaches to calculating things for the mesh. It's causing all kinds of problems. I'll go over some of those problems later in the video. So that's the folder structure. Now we're going to talk about the character blueprint. So that's in the root of the blueprint folder. The animation blueprint and the character blueprint are both under here. You'll see I have a blueprint interface, and that blueprint interface is actually being used by the animation blueprint so that I can pass values over to it without having to cast to it, which is something they probably should have done. I may go back and I may refactor their own code, but I don't want to do it just yet because of the fact that, well, when 5.5 is released, they're going to change a lot of things in the sample project, and so I'm going to wait until then to refactor their code if they haven't already done it. I'm assuming that they will have refactored it themselves by that point. They were in a rush when they released it, so a lot is probably going to change. With that being said, I should actually also mention that crap, I lost my train of thought. Sorry. Okay, so anyway, let's just move on. So here's the character blueprint right here, and you'll see that I collapsed everything into these two graphs and color coded them. This is the original logic. Some things may have been slightly modified on here, but for the most part, it's still original. Let me see if I can find anything that's been modified on here. I don't think, maybe I haven't. Okay, I have not actually modified anything in here. So I thought maybe I might have modified something, but I have not. So that's all original logic, untouched, unaltered. Over here is the KD weapon add-on. So I set up a basic and guys, I will refactor this in a later date. I just threw this together. I didn't plan it out. This is just for holding objects. I needed to test it to make sure everything worked. I have not gotten around to refactoring this, but basically it's just a structure, and it just holds an enum of type overlay state, and that overlay state holds your pistol information, so you can easily select it from here, and we can easily identify it inside of the animation blueprint or whatever. And then it holds a skeletal mesh, and it holds an aim offset for that. And you'll see the rifle has the same thing. So if we go over into our DAO folder and we go into data and enums, this is the overlay state right here, and it holds the information for the weapons. So I'm going to go ahead and close out of that and close out of this. And I'm going to close out of that for now. And yeah, I'll close out of that too. I don't know why I had that open. But anyway, so back on the character blueprint, you'll see that KD, he's the one that replicated this part of the code. I'll replicate the rest later. But he replicated the pistol and the rifle firing action, and he brought in the projectile from the third-person project. So he brought over the projectile from that, and he is playing a sound for it as well. So if you go in here, you'll see what he's doing. I modified this so that you can have two different methods. So his method is that it always shoots towards the center of the screen. And then the method that I added to it actually makes sure that it's shooting in the direction that the gun is facing. So by default, you'll see this is false. So by default, it's actually shooting in the direction that the gun is facing. So if, for example, that also means, and because I haven't added any logic for this, that if I'm like in this relaxed state right here and I fire it, you see it fired it before he was aiming it. But actually in a later version, I'll probably have it set up so that it won't fire until he's in an aiming state, fully blended into the aiming state. Right now, that's not the case, and so it'll fire, and I don't know why all hell's breaking loose over here. My phone's blowing up. I got notifications popping up over here. It's crazy. I don't know what's going on. I might have to mute my phone if I can find it. I don't even know where it's at. Oh, wait 1 second. Let me mute that because it's distracting me. I know y'all probably can't hear it, but okay, so yeah, that's the basic rundown on that. It's firing the sound right here, spawning the projectile. The projectile's using the projectile movement component to give it velocity and the given direction. And then whenever it hits, it adds an impulse at the location if it's a physics object. So if the object is simulating physics, it'll add an impulse and then it'll destroy itself. That's basically the rundown on that. I know I didn't have to go over that, but I decided to do it anyway. So that's basically the rundown on that. If we go into this right here, you'll see that it's storing the current overlay state that we are in, and that's right here. That will be under the overlay logic category. I categorized everything so that you didn't just have 5 billion variables floating around over here. I hate that. I don't know why people in the marketplace do it. I wish they would organize stuff, but to each his own, I guess. Anyway, we're setting the skeletal mesh to the skeletal mesh that is stored inside of here. And then we are setting the aim offset on the animation to the aim offset that's stored in here. And that aim offset is actually a blend space. And honestly, right now, I just I was using this to begin with. I was using only this to begin with, but I set up the AimSweep and I decided to use the up down for AimSweep, and I decided to do the spine from left to right. Later on, I realized that it seemed to me that the blend space had less issues than the spine. So I decided to just use the X axis off of this one, the left to right off of this one for the Aimoffset. I will probably refactor that later so that this isn't a 2D blend space. Instead, in a later version, it'll be a legacy 1D blend space. So that's the rundown on that. For this, I have the weight speed set to 25. If you set it too high, if you set it higher than this, it'll start looking really jittery. It already is a little jittery. And I'll go into that when I cover Aimoffset. So I'm not going to cover that right now. Actually, I am, but I shouldn't be. So I'm just going to move on. So anyway, it's going to pass this into the animation blueprint. So that's the rundown on the character blueprint. This is using that blueprint interface that I told you about. So now we can start going over the animation graph. There's some stuff that you need to know. The blueprint interface, these are the blueprint interface functions, and it's just setting these values right here. And I'll go over this one here later. There's only two places really where you have to worry about things on this event graph. If in 5.5 they don't move this stuff over to a blueprint thread safe event graph, then I'll move whatever I can inside of here over to a blueprint thread safe Anim event graph. But for now, it's in here, and it is fairly heavy on performance. So in here, I just have my Aimoffset stuff for both the spine and the blend space. Like I said, the blend space, I'm only doing it from left to right. I'm not using the up and down of the blend space, but I did make those poses for the blend space myself. Over here, we have the update additive overlay. Now I was updating this right inside of here, but I moved this over to, because this, anything that's playing on this event graph right here, this event graph, anything that's running on here is running on the game thread. The game thread is what everything else gets updated on. And so the more you have on it, the longer it's going to take to process the game thread. And so in order to reduce the overhead of updating our layering settings, I moved it over to the worker thread. The worker thread is basically anything that runs on the Anim graph, as long as you have use multi-threaded animation update checked. So I don't know if it still does that if you disable that. Maybe it does, I don't know. So that's the shooting mechanic. Oh, I didn't cover procedural, the procedural hack. Okay, I'll go ahead and cover the procedural hack. So right here you have this boolean. It's called enable procedural hack. It only actually works for this character mesh and the animations that are playing on it. I tried to get it to work with the live retargeter. I had a lot of problems, and I decided not to do it. The problem mostly is with the virtual bones. I'm not going to go into too much depth about that, but basically live retargeted characters, their virtual bones don't get updated in relation to how things are executing on the animation graph, because they're not running this animation graph. They're just copying the pose of this mesh right here, which is playing this animation graph, but is invisible. So I'll go ahead and cover this anyway. If you enable this, it'll enable the procedural offset hack. And this is basically like telling your hand to go to where the socket location is on a weapon, but it's a more proper way to approach it. A lot of people just have you, they just, let me see, if we go to the Anim graph and we go over here, a lot of people will set the effector location itself directly to the socket location, and they'll set this to be in world space right here, so that the target location for the hand is a world space location. But as I told you before, this Anim graph right here is ran on the worker thread, and everything else is ran on the game thread. And so because of that, there's a latency issue if you do it that way. And what happens is the location that it gets to tell the hand to go to is always one frame behind where the hand actually needs to be. And so the hand will come off the weapon. The lower your frame rate, the further off the weapon it'll come. So in order to get around that, the proper way to actually do this would be, well, right here you'll see, I don't know why let me see. This macro right here is the procedural offset hack itself. And so whenever you enable this, and I don't think I even have this hooked up anywhere, but whenever you enable this, it gets the effector location, the get effector offset. And what it's doing is it's getting the socket location off that held object, and it's using an inverse transform location with the transform of the virtual bone to basically, and this has to be in world space since this is in world space. And what happens is what you get returned off of here is the offset of that socket in relation to that virtual bone. And what that means, and also you can do it like this too, transform to bone space. That will return the position and rotation, which may not be necessary. But what that does is it allows us to have the hand go to the effector target location of the virtual bone, where the virtual bone should be in relation to that animation, so that he's holding the weapon. But then this effector location is the offset of the socket from that virtual bone. And so that effector location offsets the target from the virtual bone by that amount. And basically what it does is it allows us to, in real time, apply an offset to the hand. And since this is in relation to the hand, or to the virtual bone, which is on the skeleton, it's not affected by the fact that this is on a worker thread and the socket is updating on a game thread. That's basically the rundown of it. I know that sounds complicated, but just trust me. If you get the offset in relation to a bone in particular, then you will not suffer from that problem. Okay, so that's out of the way. So I'm working on the animation system right now. I'm covering all the stuff here. So I covered all the stuff on the event graph briefly, and I'm just overviewing that stuff, but then I'll cover it with these other sections that I'm coming up on. I'm just going to close out all of this stuff right here. And so over here on the Anim graph, you'll see we have the motion matching, and I've cached the motion matching so that I can use it in multiple places over here. This is experimental. I'll go over this later. As you can see, I do not recommend using this. This is basically a temporary workaround for those who do not want to wait for me to find a better solution, which is what I'm working on right now. A better solution. And yeah, I'll go over that later. Over here we have our the main part of this entire system is the layering system. So the layering system allows us to layer things over the body. It allows us to layer poses and animations over the body in different ways. And then we have our overlay state right here. These are the things that we're overlaying. We're actually overlaying the locomotion onto these poses rather than overlaying these poses onto the locomotion. And the reason why we do that, well, basically it's because we can predict the overlay state stuff, but we can't predict the locomotion. Even on a state machine, we can't predict the locomotion. And so we need to overlay the locomotion onto the overlay state since it is predictable and controllable. That's where a neutral pose comes in, but I'll cover that here in a second. I'm just going to cover the rest of this. So this is the default setup right here, the default aim offset. I'm only applying it when we're in an unarmed state. And in actuality, it looks like I may have accidentally disconnected that. I don't know how that happened, but I did do that on accident. That was not intentional. Let's actually set that to a bool. Yeah. And in actuality, I could get the state weight of the overlay state and use that. But I think that'll work fine. So I'm doing the same thing right here. I may replace this right here with the state weight as I was talking about just a second ago. This right here is the default slot. This is basically the full body slot without any additive stuff. So the additive layering will not affect it. And this is what the traversal animations play on. In some cases, you may want to play other animations on this as well. This is the weapon bone correction. And that corrects the weapon bone that I'm using to attach the weapons to. It corrects it to be how it is on the overlay state, where he's holding the weapon. And I'm doing that after the traversal. That way, when he's traversing, the traversal animations have the weapon bone in their default slot, which is not oriented properly for him to hold the gun. And so the gun will rotate in his hand if we don't do this. This is the offset root bone, which causes all kinds of problems. I don't like it. Hopefully they can improve it in 5.5. Aim offset logic. This is what's controlling the aim offset. As you can see here, I have this bound to a blend space aim offset, which, as I said before, gets passed in from the character blueprint right here. And so it gets passed in there, and then that is what gets played inside of here. I'll go over that in more detail later. Here's the leg IK. I have to disable the leg IK in certain situations. So I have a curve value that you can add to your animations. I'll go over that later. I didn't put that on here actually, so I may as well go ahead and cover it before I forget it. But let's see. So if I go into the actions, okay, here's an action animation. This is an animation montage. And you'll see I created a metadata curve. And in case you don't know, a curve has a default value of 0, but a metadata curve has a default value of 1, and you cannot modify that. So it's easy to just add a metadata curve if you need something to be 1 and you only need it to be 1. then you can just use a metadata curve. That's its purpose. And you can just add that DisableIK metadata curve right here, and it'll be 1, and that'll just mean that it gets disabled, the leg IK, and inside of here, the HandIK. The reason why this works by modifying the curve right here is because any animation that might be setting those HandIK curves to 1 over here, right here, after those set it to 1, it'll set it back to 0. That's why that works. So it's an order of operation thing. That stuff comes from over here, and it comes through here, and then this modifies it from 1 to 0. And then we have our 2-bone IK. That's our HandIK, and it dictates where the hands will go. And as you can see here, we're using a curve value called enable hand LIK and enable hand RIK. And you can do those on the animations just like I did this one. For those, if you just want them to be 1, you can add them as metadata curves. If you want to turn them on smoothly and then turn them off smoothly, then you can add a regular curve and set keyframes on it. And that's the rundown. Now we're going to talk about the layer intro. Yep, so on the layering, we have our motion matching overlay. And that's basically this if you ignore this stuff right here. By the way, I will be removing this in a later update. So you can look over it. It's not a good method, it's a hack. And that's why I say I don't recommend this. I just put it there for people who want a quick fix until I find a better solution. So this is the motion matching layer. This is the locomotion. This is the overlay state. It's mostly just poses. You can have animations in here. In fact, I do. But I'll go over that here in a minute. Over here, I just have a neutral pose. I chose the ALS neutral pose because it's a good neutral pose. And if I were to make a neutral pose, I'd probably make it like they did in ALS. And so I repurposed the ALS in pose. Just so you guys know, I did not reference ALS while I was making this. I made this from scratch without referencing anything or looking over anything. The only time I ever actually referenced ALS was whenever I was trying to figure out like exactly what his approach was for handling the layering settings for the two-handed weapons. That was the only time I referenced it. I will admit that I referenced it for that. So over here, you'll see here that I'm just caching the pose. And this is the base pose. This is the overlay pose. And then this is just the neutral pose. So down here you have your dynamic additive setup. So this basically is kind of like how they did it in ALS, but I think it's easier to understand with them separated like this. Also, it's probably a little bit more performance friendly. So what you're doing is you're getting the difference between the neutral pose and the base pose, and you're adding that difference to the overlay pose. And you're doing that every frame. And you're doing that in local space. Over here, you're doing the same thing, except you're doing it in mesh space. How do you know if it's mesh space? This make dynamic additive. If you select it, you'll see there's only one setting. It's called mesh space additive. By default, it's disabled. So by default, it is local space. If you make something in mesh space, you have to apply it in mesh space. You do not apply something that was in mesh space in local space. You will get funky stuff. Your guy will blow up like a balloon. He may shrink, disappear. I don't know. He'll do all kinds of crazy stuff. But just make sure if you apply it, if you make it in mesh space, it has to be applied in mesh space. That's just how it is. This part of it is very repetitious, and I'm basically doing the same thing for every single one of these. And these layered blend per bone, you could use a blend mask, but then you're going to have, if you come over here and you to your skeleton, and if you don't see that, you're going to go to window and you can say skeletal tree, and it'll show your skeletal tree right inside of here. Otherwise, you can press your skeleton button up here, and it'll take you to the skeleton. So if you press this gear icon, you go to blend, go to blend profiles. You could add a blend mask here, and you can give these weights. And if this is 1, and you recursively apply it, now everything on the pelvis is going to be blended onto by 100%. So I'm just going to delete that. And I'm going to come back over here. And so this basically achieves the same thing without bloating without bloating this with 50,000 different blend masks. It does the same thing. So right here on the legs, I'm on the leg layer. I'm blending anything that comes out of this. Anything that comes out of this is being applied to the legs and the virtual bones. Why the virtual bones? Well, I don't use IK bones because they're not scalable. So if your character's legs are longer, or your character's feet are bigger, or if your character's feet are more spaced apart in his pose because he's bigger, then the IK bones on this will be in the wrong place. That's just how it is. IK bones do not scale with anatomy. Virtual bones do. So that's the reason why I use virtual bones. So I just recreated that IK root tree. I recreated it right here using virtual bones. And so I'm applying whatever is coming off of here, I'm applying it to that virtual bone. That means that the animation on that virtual bone, those virtual bones will be in the position that animation was on this. What that means is that whenever you apply a leg layer, when you layer things onto the legs, the leg IK will ensure that the legs are where they're supposed to be on that animation that's coming out of here, and not where they are supposed to be on the locomotion. Now you could remove that if you want, and if you do that, then the legs will be forced to go to where they're supposed to be on the locomotion. That's up to you. So you'll see that I have the mesh space if you want to apply it in mesh space, local space if you want to apply it in local space, overlay pose if you only want the overlay pose to be layered onto it, and base pose if you only want the base pose to be layered onto it. The base is the locomotion, the overlay is like the poses of him holding the weapons, stuff like that. And these are the blend times right here. And it's just a linear blend. I'm not applying any fancy blends. You could experiment with that. I think in ALS, he likes to use, I think the sinusoidal or the quadratic one. No, he uses the cubic one a lot. But anyway, it's up to you. Also, you can add a blend profile here so that you can change the timing and say, hey, I want the feet to blend in faster than the arms, for example, or the arms to blend in faster than the feet. And that's just totally up to you. I might experiment with that too. Maybe I can improve the Aimoffset issue with that by doing that. So anyway, we're doing this on the pelvis, and you'll see that this one has a blend depth of -1. So I'm going to go ahead and explain to you what the blend depth means, because a lot of people are going to get confused by it. So say my blend depth is 2, and let's say it's the pelvis. So let's say I have a pelvis right here and the blend depth is 2. That means the pelvis is blended 50% and spine 1 is blended 100%. Everything under spine 1 is also blended 100%. Everything down the chain, 100%. If it's set to 4, that means pelvis is 25%, spine 1 is 50%, spine 2 is 75%, spine 3 is 100%, 4, 5, everything else is 100%. If I have it set to -1, that means that we are excluding that. So let's say we say thigh 1, -1, thigh L, -1, thigh R, -1. That means that the pelvis and spine 01 and everything under the spine 01 will be 100%, but thigh L and thigh R will be 0% blended. So the mesh space rotation blend, you'll see that on some of these it's checked and on some of them it's not checked. Why? Well, mesh space rotation blend just means that whatever is being applied here on the blend pose 0 will be applied in mesh space, basically how it looks in the animation. So if we look at this animation, the way it looks in here in relation to that axis, so if I go to the top down here and I close this out, you'll see we have this axis. This is basically kind of like our mesh space axis. Well, whatever is layered onto there will be applied just like it is showing here. That's what mesh space rotation blend means. If this is disabled, then that means that it'll be applied in local space. And that only really matters, I believe, if you have a blend depth that isn't 0. I'm not 100% sure on that. I don't know a whole lot of in-depth information on that mesh space rotation blend, but I do know that if you want things to be applied in local space such that, actually I'm going to go back on that. So the mesh space rotation blend, like I said, it is going to be in mesh space, but if it's not checked, then that means it will be applied in local space. So for example, over here on the arms, you'll see that we have it unchecked on this one, but we have it checked on this one. What that means is that whatever is playing right here, is going to be applied to that in local space, which means that you'll get some of that movement back in from the locomotion. This is also affected by the layer settings of everything that comes before it too, though. So let that be known. This is a local space blend, but it's local to whatever already was before. So okay. So how are we setting these? We're setting them using these variables right here. And these are just structs that I'm using to store this data. and it stores a base, overlay, mesh space, or local space, and I'm blending the poses by that enum. So I can say blend poses, and I can say the enum that I want, you see? So let's say I want overlay state. Now I can right click on here and choose an overlay state. That's how that works. And then you have to plug in that enum right here to choose which of these get chosen. So that leads me to the data asset layering data. So the data asset layering data is actually inside of here. So if we go under DAO and we go into layering data, and I didn't actually list choosers over here, but I'm going to list that anyway. I mean, I'm going to have to cover it, obviously. But if we open up this PDA overlay layering, you'll see that they're all using the same structure. They just have different labels, so we can identify them. And so you have your legs, pelvis, spine, head, your arm L main pose, arm L secondary motion, arm R main pose, arm R secondary motion. So I renamed these so that they would be more easy to understand. And each of these have a description that gives you some kind of a hint as to what their purpose is. If you want to create, I'll just go over that here. So if we go under held objects, and we go to M9, you will see we have these data assets. They're of the type PDA overlay layering. So if we go into right click and go into miscellaneous and select data asset, we can find or search for the PDA overlay layering and select it. I normally precede mine with DA underscore for data asset and then the name. Now you can give it the layering data settings for each. Now this may seem difficult. It is very flexible, but it's not actually that hard to understand because there are some rules that persist across basically every single one of these. They might differ slightly given the situation, but for the most part, it's pretty consistent. So if you're idle and you're aiming with a weapon, you want the pelvis to be in mesh space, the spine to be in mesh space, the head, you can make that mesh space if you want, or if the head is moving around too much, you might put it into overlay space and say 0.5. You have to remember that the overlay is just a pose in most cases. It might have a breathing animation layered over the top of it, and I'll talk about that here in a minute. But it's going to be somewhat rigid. So you might want to only apply a certain percent of it to the head if you do that, and that will make the head more stable so that it doesn't move around quite as much. It reduces the amount of movement on the head. 100% would mean almost no movement on the head. 0% will mean full movement on the head. 0.5 will mean that it's 50% static. On the arms, for the main pose on both arms, you want that overlay and you want it 100%. In order to introduce locomotion back into it by a certain amount or certain margin, you can leave it an overlay and you can say 0.1%. That's in the case that that hand is holding the weapon. In this case, for the M9 idle aiming, he is actually holding the weapon with both hands. And if this doesn't crash, and I hope it doesn't, Okay, cool. So if I pull this out and I aim, you'll see he aims with both hands when he's idle and aiming. When he moves, he's only aiming with one hand. So how do I get his left hand to move like it does whenever he's aiming with the rifle, with the pistol with one hand, without making it stiff like it was in the other one? So I'll go ahead and show you now. So on the M9 running aiming, you'll see that for the secondary motion of the arm L, I do have the main pose still at overlay in 1.0 that stabilizes it. But on the secondary motion, I'm setting it to base 100%, and that stabilizes it. And so you can modify these in real time, and I'll go ahead and show you that now. So if I set this to base and I aim, you're not going to really see much of a difference here, mostly because I'm assigning it to base. So actually on this one, you can actually set that to 0, and you're not really going to see any difference. That's because I want the base to be in local space. But if I set it to base mesh space, you'll see how it looks. So that's how the arm is actually moving on the base. So if I say 0 right there, you have to remember that the arm L, like I said before, everything that precedes these, this is working from top to bottom. These are being applied from top to bottom. So the pelvis is in mesh space 0.2, but the spine, that's what matters. The spine overrides the spine and arms on this one that were applied in mesh 0.2. It's overriding that with mesh 1.0. Over here, you're not overriding it with anything because this weight is 0. But over here, you're overriding the arm that is in mesh space 1.0. You're overriding that with a local space blend of 1.0. So it would kind of be like, having this in mesh space 1.0 and then applying this in base. And that's the secondary motion. And so you'll see we get the same effect out of it. And if I say 0, you won't see a change because it's still being applied in mesh space. So it's important to note that if you're applying it to the arm already in mesh space and you want it to be applied in mesh space for the main pose, then you don't have to do it again on the main pose. But if you want it to be overlay, you have to apply the weight or it won't be applied. Then it goes back just a little further, I think. Nah, not much of a difference really. Yeah, you're not going to see much of a difference on that one. In some cases, you're not going to see much of a difference between overlay and mesh space. Not when you're applying secondary motion back to it at 100%. If you apply this only in 0.5% though, you will see a difference. So I'm only applying the base 50%, but I'm applying the overlay 100%. And so you'll see how much stiffer it is. But if I set this to 1.0, then it basically ignores that stiffness that was applied before. So if you only want this to be partially to add a little bit of locomotion into it, then you can do that. And you see it moves a little bit, not much. If I say overlay, then you'll see it almost moves not at all. It almost doesn't move at all. But if I say overlay 100%, you'll see it moves back and it's moving a little bit more now. And if I say base 0.4, you'll see it's still pretty stiff, but it's respecting the way the arm is in that animation pose a lot more now. But for the most part, you probably just want it to swing like that. So it depends on the situation. If he's holding a gun with that hand, then you don't want it to swing. You don't want it. You don't want the secondary motion to be high, if any at all. And so you'll see on this one, I'm applying it in mesh space 100%, but I'm only applying it just barely in local, as I'm only applying the secondary motion to it just by 10%. And that allows the gun to move around. If you don't, it'll still move around a little bit just because the body is bobbing up and down, and so is the spine, but it'll be a lot stiffer now. And so it's hard to tell the difference, but there is a difference there. I should note, though, that if you apply the secondary motion to it, it does slightly offset the aim. So you should take that into account when you're doing that. That's why I would not recommend putting this any higher than 0.2 if he's holding the weapon. If this is the hand that he's aiming the weapon with, I would not apply secondary motion any more than maybe 20%, 20% or 0.2. So that's the rundown on that. Now, how is this getting updated? As I said before, I was updating it right now, but now I'm updating it on the overlay state. On this function right here on update, I'm updating it right here. And this gets ran and executed on the worker thread, which reduces the load on the game thread. That should increase performance under heavy loads. So by default, I have this variable. It's called testing. It is set to true so that this will always execute. That allows us to update this in real time and watch it reflect inside of there. If not, if this isn't the case, then if you have this set to false, then it'll only update if this is set to true. And if it's set to true, then it'll update it and it'll interpolate the values inside of here. So it'll interpolate that value so that it doesn't snap to a new position. It'll interpolate it, and then afterwards it'll turn itself back off. So I'll explain to you exactly how this is working. So it gets set to true from the event graph, actually, whenever we update any value. So if we want to aim, then I use this macro, and this macro, if the new wants to aim is a different value than the current wants to aim, if the current wants to aim is a different value than the wants to aim, then it'll set this value to true. And it does this on other stuff too. If we start moving, and there's a few other places I use it as well. You can actually right click on that macro and find references, and you'll see where all I'm doing it from. So whenever I update the gate state or the layering state, I set it to true, and that allows this to execute. And so it'll execute this, it'll come in here, and if we are not playing something on the overlay full body slot or the upper body slot, then it'll evaluate the chooser and it'll update the current layering settings. Then I have this helper function, which I just pass in the values to, and it'll update this local variable. It's global to the animation system. It'll set it by reference inside of here, and it'll interpolate the layering weight value, and then it'll turn itself back off. And it does this for each and every one of those. That's basically the rundown on that. Oh, I did not cover the chooser. I said I was going to cover the chooser. I need to cover the chooser. So you have your chooser table in here, and these are nested choosers. I'll show you how to create a nested chooser. You can go to Add Row, Nested Chooser. You can press this and say New Nested Chooser. and now you have to name your nested chooser. You can also go over here and select from an already created nested chooser. And then you can highlight this right here and press delete on your keyboard to delete it. So I have these. So if you go to your layer, your table settings, I have the context data coming from the animation blueprint sandbox character. That's the one that we're using for the character on this mesh right here. That's the one assigned to it. So it's getting that, and once we get that, we can add a column, we can add one of these, and we can go over here and we can choose our overlay state. Or we can make this a Boolean, and we can bind to one of these. Wants to aim, for example. That's what I'm doing. And then I'm setting this, and you can say equal, not equal, or any, but I want this to be equal. So if this current overlay state is set to pistol, then it'll evaluate this one. Inside of this one, it'll choose one of those data assets that we created and modified. It'll choose one of those based off the movement state and then wants to aim. Now I do have gate in here because we will probably need to consider that later. Right now we're not actually considering it, but it's in here anyway for when we do. And I'll probably have to consider that once we go into sprinting. Once sprinting and crouching gets added, we'll have to take that into consideration as well. So that's basically it. If we're idle and we're not aiming, we choose the idle rest. If we're idle but aiming, we choose the idle aiming. If we're moving but we're not aiming, then we choose the running rest. And if we're moving and we're aiming, then we choose the running aiming. We do the same thing on the rifle. And that's basically the rundown on the chooser table. So it chooses one of those based off of those settings, and it sets it right here. Now we're going to talk about the overlay state. Also, I am going to go ahead and tell you that doing this is actually more expensive than in multiple places. Doing this in multiple places is actually more expensive than just grabbing it from a Boolean value. That's why I'm caching these, because I'd rather take up 8 more bytes of memory than have to reprocess this multiple times within a given frame. That's a lot of stuff to process every frame. Also, I should tell you too that doing this, getting these things thread safe from a character that's external to this is actually more expensive than caching it. That's also true. It may be thread safe, but it is more expensive. So let's go ahead and cover our overlay states. So over in the overlay state, I just have a state machine. And right now I only have 2 states ready and aiming. I don't have a relaxed state yet. I may add that later. I know that's what they do in AOS, and it does add another layer of movement to it to make it seem more fluid and realistic. So I may add that in a later update. But right here, I'm just saying wants to aim. And the reason why I'm doing the state weight is because in some cases, if I don't do the state weight, we might exit aiming whenever we're doing a hard turn. We might exit aiming, come back into ready, and then go back into aiming multiple times within a single frame. And so in order to prevent that, I'm telling it, hey, don't re-enter the aiming state until the ready state has blended in at least 90%. If you're not at least 90% blended in, then you have to wait before aiming. To exit the aiming, we have an aiming threshold, aiming offset threshold. And basically what this does is it allows us to stop aiming when we look too far behind us. If we're looking too far behind us, outside of the range of our aim offset, then we want to go back into ready. And that just makes it look a little cleaner, I think, whenever he drops his rifle as he's looking around and turning around, and then he'll aim it again. And that's basically, I'll actually show you that now. So that's the effect. Now, it is a little snappy, and that's because I have the, that's because some people want this to be really, what's the word I'm looking for? They want it to be really responsive, and that's the reason why I did that. I may go into how you can actually reduce that. Yeah, actually I will. I'll go into how you can reduce that so that it's not that snappy. But it'll be less responsive if you do, just letting you know. So inside of these states, we're doing the blend pose using the enum overlay state. So over here, if you move over here and you look under the functions, I didn't cover this, but I should have. You'll see my additive overlay stuff right here. That's where everything is under. And under the variables, it's under overlay. And I have everything categorized in here. There's a few floaters down here, but I'll probably categorize them later. But if we look at our current overlay state, that's just what weapon we're holding. And so if we're holding the rifle, then we choose the rifle anim layer. And that's just an animation layer right here. And you'll see I have these grouped. And I'll probably rename these and restructure this later. I've already done it in another project, but. So we're choosing that based off of the current overlay state. I have it bound right here. And then we're applying an additive, which is the breathing. I told you about that before. And I'm only applying 50% of that breathing additive. And what that does is it allows us to reduce the amount of movement that breathing additive adds over the top of this. And so for a ready state, you're probably not going to want a whole lot. You don't want it to look like he's hyperventilating. And that's the reason why I set it to 0.5. You might even set it to 0.25 to make it a little more subtle. It's completely up to you. So on the pistol armed, I'm just saying you can open these up, and I'm going to go into the perspective mode. At 0.04 right here, this is the pose that we're choosing for true. If we should move, we want this pose. And the reason why is because it's a neutral pose. So we need this to be a neutral pose for the lower body, or else it won't look very natural whenever he's running. And that's why we're applying that when we should be moving. So the pose that you play should be neutral. And what neutral means is that his hands are basically by his side and his feet are right underneath him, and they're in a relaxed state where they're not real spread apart and they're facing forward, generally facing forward. And he's looking forward. So it's a neutral pose. And so if it's not a neutral pose, it can cause problems whenever he's running. Whenever he's idle, you don't have to have it in a neutral pose. You can put it in whatever, but it needs to respect whatever posture his lower body currently has. Otherwise, he may be twisted off to the side and it'll look funny. So he needs to be like, if his left foot is forward here, then his left foot should probably be forward in that animation as well. So when he shouldn't be moving, I'm just playing this one. And so you'll see there's not much of a difference, but this leg is slightly back. And his pelvis is slightly twisted to the side on this one. So there's just a subtle difference there. Not a real big difference. Almost not even enough to even bother. But anyway. So right here, based on the speed, we're going to blend between this and this. So if the speed is 300, then we'll be 90% blended in to this and 25% blended into this. If the speed is 0, we'll be 25% blended into this and 75% blended into this. And so why? So if we go over here and we scrub to 11, this is the pose. Also, these poses need to be set to step if it's a pose compilation, or else it'll interpolate between these frame markers, and we don't want that. It causes problems. So here, it has him with his hand in the air, and this is for when he's not aiming. And the reason why I'm doing it like this is because I'm blending it halfway between this and this. Well, a percent. I'm blending it a percent between this and this. And the reason why is because I don't want his hand to be completely straight up like this, because when he stops, it causes his hand to swing back. So I kind of blended it to around right here. And that's why it's set to 90% and not 100% when he's running. That way, whenever he stops, his hand doesn't come back into his shoulder. Or it keeps his hand from clipping into his shoulder. On this, I'm not doing anything as fancy. I thought I deleted that, but apparently not. Right here on this one, I'm just saying this or this. And I'm blending it only 25% into this, which is where he is holding it like this. And I'm doing that when he's running. And I'm not sure I even need that now. I think that's how I was doing it before, and I just never went back and looked. Let's see what kind of problem we have here. Yeah, that's not even needed anymore, guys. So if you leave it there, his hand will probably actually come off the rifle. Yeah, so that's actually not even needed. I might just be removing that. That was before I worked out all the problems. That was a fix that I had. So I'm not really doing anything fancy on this one. I might later on, but for now, I'm not. So aiming, not much to it. I'm only applying the breathing 25% during aiming because I don't want his arms to be moving a lot while he's aiming. And then I'm applying the AimSweep additively in mesh space to this pose, which is this one right here on the pistol. And this is the AimSweep. And that AimSweep is being driven by this right here, which is being set. And we went over this before, but I'll show you again. It's being set by the get Aimoffset value, which is what they use for their Aimoffset as well. For the left to right, that's for the up and down. For the left to right, we're actually doing it a little differently. So I'm clamping it between -90 and 90 because the left to right only goes from 90 in one direction to 90 in the other direction. And actually, I currently do not have interpolation set up. I thought I did. That might have been why it was snapping earlier. I must have disconnected that for some reason. Let's see. Yeah, so the reason why it was snapping is because I must have disconnected it. You'll see it's not snapping anymore. So that prevents that snapping. But like I said, it makes it a little less responsive. So if you want to bypass, if you want to use it, just connect this back up. If you don't want to use it, bypass all of this stuff right here. So it's up to you. I'll have it disconnected by default, but that's how you can add it back. And I have this as a constant because I don't want it slowing down or speeding up. I want it to interpolate at a constant rate. Also, if you enable spine-based AO, it'll enable the spine-based one, and so you can switch between the blend-spaced left to right and the spine-based left to right to see what the difference is. I think the spine-based left to right is slight. It hitches just a slight bit more, in my opinion, but maybe it doesn't. I don't know. It could be an optical illusion on my part. At one point, it looked like it did. I went back later. It looked like it was hitching just as much as the other one. So I don't know. Yeah, I kind of went off on a tangent there, guys. Sorry about that. I completely got sidetracked and stopped looking at that altogether. But yeah, that's because this part of that is right here. Yep. And if we should move, then we do 0.18, where his feet are side by side in a relaxed neutral pose. And if not, then we do this one, where his hand is down by his side. And so actually, because this is a pistol aiming, that's actually not even necessary. I don't know why I even have that connected. It should still work the same. Yeah, I changed a lot of stuff and I failed to go back and look. Yeah, so you'll see it still works the same. And the reason why is because we're actually leaving the aiming state, and therefore we don't actually need this anymore. That's just extra bloat that's unnecessary. Same with this one. We don't need that anymore. That was before I worked out all the problems, all those problems. So this will be disconnected in a later update. If you're watching this a week from now, then it's already been removed. It'll still be sitting here, but it won't be connected. I'll leave it sitting there in case I end up figuring out that we do need it for some reason. But yeah, so that's the overlay state, guys. And the overlay state, it gets layered onto the motion matching state right here, using different weight values and different spaces depending on whatever you set inside of those data assets. So montage slot layering. So I need to go back over that. So you'll see that on the update layering data, I'm bypassing the chooser evaluation right here, which will set the current layer settings based on the chooser whenever we're playing something on this slot, on one of these slots. And the reason why is because if we don't, and we choose to pass in a data layering setting along with the montage that we're playing on one of these slots, then this will overwrite whatever we passed in. Therefore, we need to make sure that it's bypassed whenever we're playing something on one of these slots. And these slots are on the layering. And so you'll see that I have all kinds of slots on here. For the most part, you won't be using these slots. These are special use case scenarios where you might use one of these. But for the most part, you're just going to be using one of these. So for the upper body one, for now, this one is only for the pelvis up. If you try to layer something onto the legs with it, it's not going to blend smoothly, and I'll go ahead and explain why. So when you blend in and out of this overlay upper body, it blends in and out of the source, and that's it. Since the overlay pose that we're using on here is coming from the overlay state, that means only the overlay state will be blended in and out. The motion matching will not be blended in and out. For that, we need the overlay full body. So if you play it on the overlay full body, you might want to, and let me see, I have an example here that I set up for you guys. There is under animations, DAO anims, actions, you have this layering slot. And so on this one, I'm actually setting the layering settings that I want for the overlay state while I'm playing this montage. And what that does is, if you didn't do that, if you weren't, and I'll actually show you. So let me just go over to the event graph, and I have this example right here. So I'm playing this animation montage right here on the overlay full body, and I got DisableIK set right here. But before I play that montage, I'm using this blueprint interface function, which I told you about before, this one right here, which gets passed in right here. It will enable should update layering data in case you, let me just find it here. In case you disable this, you need this to be set properly. So this will be enabled so that this will execute when we're not testing. And like I said before, after it finishes interpolating, it'll set that back to false. So we pass in that data asset right here, and it overrides the layering settings for the overlay state while we're playing that animation, and I'll show you what that looks like. So if I'm in an overlay, and this only works when I'm in an overlay state. Oh no, it doesn't. It works. Yeah, it only works if you're in an overlay state right now. Because when we're in an unarmed state right here, when we're in this unarmed state, and I messed up the pistol settings earlier. I'll have to fix that. You'll see how stiff it is because I was playing around with it, showing you guys. But when we're in an unarmed state, we're not layering at all. But when we are in an overlay state, the overlay, let me just show you. So nothing in here gets executed. Nothing in here is accessible when we're in an unarmed state right here. When we are in an overlay state, this slot will be accessible. When we're not, this slot doesn't even exist as far as the animation system is concerned. So nothing that plays on this will play if we're not in an overlay state. But if we are, I can play that. And you'll see it looks pretty smooth. There is a little bit of foot sliding, but I'm going to experiment with a foot locking system to fix that. But if I bypass this, I'll have to stop it to bypass it. If I bypass it so that we don't override that, and I play it and enter it, and I play it, you'll see that the hands never come off the rifle. And the reason why is because on the rifle one, we have this set to overlay. And on this one, we're saying, hey, we want to play the base locomotion on this one. And since before the overlay is layered onto the base locomotion, we are playing this overlay full body slot. This overlay full body slot will override anything on this. And so you're actually layering the overlay state onto that animation that's playing on this, the Montage that's playing on this slot. And this allows you to override the settings on it whenever you play it. But you have to set it beforehand. And that's basically it for that. Sorry, I'm having technical difficulties over here. Yeah, there we go. All right. So now, Jesus Christ, we're almost done. So much to cover. Yeah, don't be expecting me to do this after every update, guys. Yeah. So as I said before, this is like the post layering full body. It'll override anything that comes that's plugged into the source. It'll override anything on it. And so the traversal animations play on this. The problem is like I said before, the traversal animations have their own position for the weapon bone. And so after that, we get the weapon bones and we say, hey, we want the weapon bones to be where they were on the overlay state so that he's holding the weapon in approximately the same manner. when we're in an unarmed state, we don't even have to worry about that. Aimoffset, I've partially covered this already. But if we're not in an unarmed state, then we can Aimoffset. And if we're not flying, meaning that we're traversing, if we're traversing, we go into fly mode. And that's because they use motion warping. And so they need it to be in flying mode in order for motion warping to motion warp through the air. Otherwise, it'll just motion warp across the ground. And so I kind of took advantage of that fact to say, okay, don't Aimoffset if we're traversing. If we are, though, you'll see if we are and right. So if we are Aimoffsetting, then by default, then we're going to be using the blend space right here. After the blend space, we do a weapon finger correction. The reason why I do the weapon finger correction on all the fingers for each hand right here is because the blend space does have their own finger positions. I did not match the finger positions. And so depending on the gun too, the fingers might be in different locations. And this is applied in mesh space. So it can negatively affect the fingers, make them bend funny, since it's being applied as a mesh, mesh space additive. And so I just place the fingers back where they were on the overlay state. I don't have to worry about that for the spine. So if we are using the spine, as I said before, you can check this and it'll convert over to the spine-based. I'm not sure what I was doing with this. I think it was an experiment. And if this is disabled, it just doesn't do anything other than maybe disable the IK if the DisableIK curve is set to 1. It'll disable it for the hands. Right. Aimoffset update. I basically went over that, I guess. Aimoffset issues. Okay. So you may notice that when you're rotating, the gun doesn't stay perfectly aiming at where it's supposed to be aiming. It kind of jerks back and forth as you're rotating. That is actually not my fault, and there's not anything I can do about it right now. That is being caused, I believe, and I'm not 100% sure, but I am under the impression that is also being caused by the offset root bone. The offset root bone node offsets the root bone in relation to the actual mesh on the character. And so if you see the transform of this right here, this is the transform for this mesh component. This mesh component does not get offset, but the root bone of the character and everything connected to the root bone will get offset way over here somewhere. Not that far away. I'm over exaggerating to get the point across, but it'll be offset over here in order to prevent foot sliding. And it does that by analyzing the root bone animation or root bone motion on the animations themselves and offsetting the root based off of the velocity and direction of the root bone in the animation versus the velocity and direction of the character in world space. So it'll offset it off over here somewhere, which that also means that you can't you have to calculate your aim offset based off of the root bone and not the mesh. Normally you do it based off the mesh, but you can't do that if you're using this offset root bone because it won't be accurate. He'll be aiming in the wrong place. And because of that, it causes jittering. That jittering is caused whenever this offset root bone rotates the root on the character that we're calculating that aim offset from. That's what causes that jittering. HandIK, I'm applying this as a curve. I decided to do this as a curve. So if we go over to these poses, for example, the pistol idle aim, you'll see enable HandIK is set to 1. I could have made that a metadata curve. I didn't for whatever reason. I probably should have, but it's not that big of a deal. So anyway, if that's enabled, then his hand will be placed at this effector location, which is controlled by these, well, by the virtual bones that are attached to the weapon bones. So I made these virtual bones based off of the weapon bones because this character uses weapon bones. And in some animations, you need the weapon to rotate in the hand during the animation. And so you can animate those weapon bones to rotate the weapon in the hand whenever you're making the animations. If you don't want that, in some cases, that's necessary in order to keep from having to bend the wrist at a 90-degree angle, which looks really funny and causes a lot of pretzel twisting or balloon twisting problems with the weights, where your wrist will just completely lose volume and it'll look like it's twisted like a pretzel. And that's the reason why weapon bones are important. Some kind of bone, you could use the IK handgun bone, but you would need to position it and constrain it and all that. If you didn't have any animations that needed that, then you could actually just create the virtual bones off of the hands and use those as the targets, the effector targets. Take rotation from effector space means that it'll rotate the hand to be oriented to that virtual bone, the rotation of that virtual bone. The joint target, it's like a pole arm. If you're familiar with Blender or Maya, you have those pole arms, and that just keeps this right here. It keeps this oriented in a specific position to keep it from bending backwards and doing funky stuff. And obviously we're doing this to the hand. So that's basically it on that. I'm not going to go into too much depth on that. The reason why I'm doing that is because whenever we apply additives over the top of things, the additives are sometimes applied in local space, which can say, if this is pointing this way, and I apply something that moves it in this direction, then it'll move in that direction. But if it's pointing, if the top of the forearm is pointing in that direction instead, and I apply something that moves it that moves it in the direction of the top of the hand, then it'll move in that direction instead of this direction. But those virtual bones will still maintain their offset on those hands. And so we can tell it to place those hands back to where they need to be. And that's basically it. Oh yeah, so we have this experimental one. You can check this to enable it, and you'll see that it offsets the pose completely using a layered additive technique. And I'm just placing the hands back to how they were right there. That's all I'm doing on that one right there. And then this is just doing a two-way blend back with the base based off of the speed to blend back out of it whenever we start moving. So this is experimental. There are some problems, like if you're running forward and to the left, sometimes the legs will clip. Or the legs will do funny, yeah, so see? In some cases, the legs will clip. They'll cross each other whenever they blend back into that pose. You seen that? So that's the reason why I said it's experimental. It's not great. It does somewhat work, so some people might like it. So for now, I'll leave it in there. But I am working on a better solution. And so, yeah, I'll see you guys in the next video.